So this seems to be the problem on foundational exam number 2 that's giving people the most problems. So I'll go through it. I'm going to show the correct way to do it. I'm going to show the incorrect way that a lot of people end up doing it. But I'm also going to try to explain, give some intuition for why the incorrect way is incorrect. So the problem will go something like yogurt or some other commodity is on sale for, say, $3.59 for this example. And this is 25% off its original normal price. And then the question is, what was its original price then? So you're given 2 pieces of information. You have to find a third. So the correct way to think about this is, I like to think of the prices as actual objects with sizes. So you can almost think of this as like a stack of dollar bills that, here this green rectangle maybe represents a stack of dollars and a bunch of change adds up to $3.59. So if you take 25% off of an item in a store, what that means is you take the original price and you subtract 25% of that original price from itself. And so the way we would express this visually is, here where we have the original price with this orange rectangle, the little shaded in pink part represents 25% of that. And if we chop that off, now we're left with the discount price, $3.59, represented here by the green rectangle. The way you would represent this relationship with an equation is like this. So you'd say $3.59, green rectangle, is equal to the original price, big orange rectangle, minus 25% of the orange rectangle. So this minus 25% of P corresponds to taking this shaded pink part here and chopping it off and tossing it off to the side. And then from here, you can just rearrange this. So I'm using the distributive property backwards here to collect the P on the outside. And then you get 1 minus 0.25, which is 0.75. And now we can divide both sides of this equation by 0.75, which leaves us with the original price P on the left, and 3.59 divided by 0.75. In this case, 4.79 was the original price. Now, what a lot of people will do is, instead of subtracting 25% of the original price to get the new one, they'll add 25% of the new price to get the original. And that's just not how discounting something works. As an extreme example, if something is on, it costs $100, and you put it on sale for 99% off. I'm sorry, I should have written this in orange with my color code here, but if something, its original price is 100, and you put it on sale for 99% off, that means its new price is going to be $1. But that doesn't mean you can get the original price by adding 99% of $1 to itself. Because if you do that, so if you add 99% of $1 to itself, you get $1.99. Obviously a lot less than $100. So you could think of, so here I'm going to visualize the incorrect way. So if you have the discount price, $3.59, and you take 25% of it, represented by this top little shaded square here, and add that to itself. So we're adding 25% of the discount price to itself. This is going to be less than the original price. So here we can work out the equation. So in that case, if we tried to calculate the original price this way, we would get that the original price was $3.59 plus 25% of $3.59, which is not the right answer, $4.79, it's $4.49. So the problem with the incorrect method comes down to the fact that if you have a big number and a small number, 25% of the big number is bigger than 25% of the small number. In this case, the big number would be the original price and the small number would be the discount price. And so you can't get the original price by adding the discount percentage of the new price back to itself. You have to do something a little bit more slightly complicated. But yeah, as long as you can stay clear of that, this is how you do the problem.